Bismillahirrahmanirrahim. This brief video will introduce an online course on real statistics based on a radical new approach which will be offered starting this September 2021. Conventional statistic, which we'll also call Fisherian statistics, is based on an ingenious approach developed by Sir Ronald Fisher, which was based on reducing a large data set to a small number of parameters. This was necessary because at that time computational capabilities were severely limited and it was not possible to analyze a data set of 100 points or 1,000 points directly. So Fisher developed this ingenious assumption that he assumed that the data was distributed according to some parametric distribution like the normal. When you make that assumption, then the data can be reduced to two numbers, just the mean and the variance. And by this method, one can analyze very large data sets just as conveniently as small data sets, all of the data sets just reduced to two numbers. So this was a brilliant maneuver for a situation when computers were not available. One can go beyond the normal distribution to parametric families of distributions which have more than two, but generally speaking a limit number 3, 4, 5 parameters. And again, we end up with this miracle that 1,000 points of data or 1,000,000 points of data can all be analyzed by only looking at 3, 4, or 5 numbers, the parameters of the distribution. But this magic is created by making an assumption which is completely invalid. And in modern age, with computers around, it is unnecessary and highly restrictive. You might think that non-parametric statistics solve the problem because now we no longer have parameters, but in fact this is also based on the same assumption that the data is a random sample from the same distribution, although this distribution is now allowed to be general. But this assumption is also unnecessary and highly restrictive, and it is possible to do data analysis without making any such assumptions today, because we have the computational capabilities. Fisherian statistics has been rendered obsolete by a massive increase in computational capabilities. If you examine the original writings of Fisher himself, he was aware of this possibility that his methods would no longer be necessary if there was a suitable amount of computational power available. But later on, his followers just took his framework for granted and never examined the reasons, and it has become firmly entrenched as statistical orthodoxy, and nobody today questions why we make this assumption. So the entire methodology which has been developed over the past century can be scrapped. So this video is introducing a new online course which we call Real Statistics, a Radical Approach. And this describes just a few of the key features and innovations in this introductory course. To begin with, statistics involves summarizing the data, and the standard summaries are the mean and the standard deviation. These are the optimal summaries for a normal distribution. It turns out that these are also the worst possible summaries for the general case. Worst possible can be defined in a technical way. These statistics have 0% breakdown, which means that even a very small percentage of bad data in a large data set can completely destroy these statistics. As opposed to this, natural summary statistics are median and interquartile range, and these have high breakdown values. So unconventional source would, such as mine, would omit discussion of the mean and the standard deviation and replace them by the median and the interquartile range. In a conventional course, we spend a lot of time on the theory of the normal distribution. All of this can be completely dispensed with. Instead, we need to teach students how to think directly about the data, to visualize it, to plot it, and all of this is easily possible with Excel and more advanced visual graphics programs. So our course starts by introducing basic concepts in a very intuitive manner. This involves how to compare two numbers to decide which is larger, and in particular, when this is done through indexes, to understand that this comparison of indexes is always fraught with problems because of the arbitrary assumptions involved in creating indexes to summarize data. A diagrammatic picture of how real statistics differs from Fisherian statistics. And basically, we have hidden structures of reality which generate the observable structures. The observable structures can be quantified and measured, and that is where we get the data from. And then we have a theoretical model for the data. And basically, Fisherian statistics deals with theoretical models and data. But these theoretical models are purely imaginary. Real statistics tries to get at the hidden structures of reality which generate the observations. And so it looks at the link between the data and the observations and how the observations are generated from hidden structures. So the agenda of real statistics is entirely different, and it deals more or less directly with the real world, as opposed to Fisherian statistics, which deals with theoretical imaginary models. Within our real statistics approach, there is no such thing as abstract data analysis, taking a collection of numbers and analyzing it. One has to relate the numbers to the real world origins of the data. So we look at practical real world applications of statistics, such as the GNP numbers and how they are index numbers and fairly arbitrary. We look at life expectancy, how it is calculated, what it means. We look at some basic binomial probability models because we need these to interpret the data in slightly broader sense but this basic binomial probability is all the theory that is needed. We don't need advanced and complex theory. In particular, these binomial models help us to assess whether or not two data sets are independent, and independence is a key to the understanding of causal relationships, which are at the heart of statistics. In conclusion, what the takeaway from all of this is that Fisherian statistics assumes that the data comes from a parametric family of distributions. This assumption is purely for computational convenience. It is not valid. It has no genuine relevance or utility. The only utility it had was for an era where there were no computers. A vast paraphernalia of methodology has been developed which discusses the theory of statistical inference in the context of how to estimate, how to do hypothesis testing, and how to do a lot of things for these parametric models. But all of this is pure nonsense. It is no longer required because those parametric models are no longer necessary in this age of massive computational capabilities. And I have developed a new course outline which dispenses with this idea of parametric family of distributions. And this online course provides just the introduction, the ABCs. An entirely new structure of inference needs to be constructed for this non-Fisherian approach to real statistics, and more advanced work is on the way. But this basic course will provide the basic concepts needed as building blocks for the more advanced materials. More information about the online course is available from this link on this page. Later on, we will provide this course at a modest fee to cover costs. Right now, the link is open and available to anyone who wants to take the course. For free registration from this September, as a beta test, students can enroll directly and take the courses. Teachers of statistics who would like to use this approach under my supervision are invited to contact me directly. I would like to work with teachers to familiarize this approach and to make it available all over the world. In particular, my former students are invited to try to teach standalone statistics courses based on this approach. It is worth noting that this will not be a useful approach in a 2-semester course where statistics is being taught as an introduction to econometrics or to other more advanced applications, because currently more advanced applications like econometrics rely on knowledge of Fisherian statistics, which this course will not develop. Later on, as we will develop advanced alternatives to these advanced statistical courses also, but at this moment those alternatives are not available.